Picture a single ship, a single afternoon, and 24 rabbits stepped off a gangplank onto Australian soil. Nobody screamed, nobody ran, nobody thought to raise an alarm. It looked, if anything, like a gift, a small taste of home for a homesick Englishman living on the other side of the world. That gift would grow into one of the most catastrophic ecological disasters any continent has ever endured. And more than a century and a half later, Australia is still bleeding money, soil, and species because of it. This is the story of how a handful of soft, twitchy-nosed animals brought a nation's environment to its knees, and why, even now, with satellites, viruses engineered in laboratories, and billions of dollars spent, the war against the rabbit still isn't over. To understand how something this small became something this big, you have to go back to 1859 to a property called Barwon Park near Winchelsea in Victoria. The owner was a wealthy grazier named Thomas Austin, a man who had grown up in England, surrounded by the traditions of country sport. Hunting was in his blood. Shooting rabbits on English estates was a weekend ritual, a mark of status as much as leisure. When Austin emigrated to Australia, he found a continent with no rabbits at all, no native population, no wild cousins, nothing hopping through the scrub. So he wrote to his nephew back in England and asked for a shipment. He wanted grey rabbits, hares, partridges, and a few sparrows, enough to recreate that same weekend ritual on his new estate. His nephew couldn't find enough wild grey rabbits to fill the order, so he padded it out with domestic ones instead. In October of 1859, around 24 rabbits arrived at Barwon Park and were released into a purpose-built enclosure. Austin's own words at the time captured just how harmless the whole thing seemed to him. He believed a few rabbits could do little harm, and might even bring a small touch of home along with some sport. It is one of history's great understatements, because not long after their release, a fire tore through the enclosure fencing. The rabbits that had been safely contained suddenly weren't. They spilled out into the open Victorian countryside, and Australia, a continent that had never in its geological history hosted a European rabbit, was about to discover exactly what that absence had been protecting it from. What happened next defies almost every normal expectation of how animal populations grow. Within just 3 years, hunters on Austin's own property had killed 14,000 rabbits, and still considered the population barely dented. By 1866, local newspapers reported that 50,000 rabbits had been shot on that estate alone, but shooting them didn't slow them down. It barely kept pace, because rabbits breed with a speed that borders on absurd. A single female rabbit can produce several litters a year, with anywhere from 4 to 12 kits per litter. And those kits themselves are capable of breeding again within just a few months of being born. Do that math across a landscape with no natural predators built to stop them, and you get exponential growth of a kind evolution never had to plan for on this continent. Australia, it turned out, was almost perfectly designed to make the problem worse. There were no foxes yet to hunt rabbits in serious numbers, because foxes themselves were a later European introduction. There were no large predatory mammals evolved to specialize in rabbit-sized prey. The climate across huge stretches of the country was mild enough that rabbits could breed nearly year-round instead of being limited to a short, warm season like their ancestors back in Europe. And the soil across much of the southern and central regions was soft enough to dig, perfect for the underground warrens rabbits used to shelter, hide from what few predators did exist, and raise their young in relative safety. It was an open invitation, and the rabbits accepted with terrifying enthusiasm. The spread that followed is now considered the fastest recorded invasion by any mammal anywhere in the world. Within 70 years of Austin's release, rabbits had colonized roughly 70% of the entire Australian continent. Think about the scale of that for a moment. Australia is nearly the same size as the continental United States. Picture an animal the size of a large cat spreading across the equivalent of the U.S. mainland east of the Rockies, west of the Rockies, north to south, in less than a single human lifetime, using nothing but its own legs and its own extraordinary rate of reproduction. There was no railway carrying them, no ship, no deliberate transport network. They simply walked, dug, and multiplied their way across an entire continent at a pace of roughly 60 to 80 miles a year in some regions, faster than colonial authorities could organize any coordinated response. And as they spread, they devastated everything in their path. Rabbits are selective grazers, and that selectivity turned out to be one of the cruelest parts of the whole disaster. They don't eat everything indiscriminately. They target the tastiest, most nutritious young shoots first, the very seedlings that native trees and shrubs need in order to regenerate and replace older plants as they die off. Researchers would later calculate that it takes less than 1 rabbit per hectare, a shockingly low density, to completely halt the natural regeneration of many native tree and shrub species. Multiply that across millions of hectares of infested land, and you get a slow, silent strangulation of the Australian bush. Forests stopped renewing themselves. Understory vegetation vanished. Topsoil, no longer held in place by root systems and plant cover, began to erode at alarming rates, washing away in the rain or blowing off in the wind, taking generations of accumulated fertility with it. Farmers watched their pastures get stripped bare, grazed down to bare dirt by rabbits competing directly with sheep and cattle for the same feed. Wool production, one of the backbones of the entire Australian colonial economy, took a direct hit as pasture land degraded under the pressure of rabbit grazing, layered on top of livestock grazing. Entire farms were abandoned at the peak of what became known as the rabbit plague, families walking away from land that could no longer support them because the rabbits had eaten it into ruin before the sheep ever got a chance. The scale of agricultural loss became so severe that in the 1880s, the government of New South Wales offered an enormous cash prize, something in the realm of £25,000 at the time, an almost unthinkable sum, to anyone who could come up with an effective method of destroying the rabbit population. Nobody claimed it. The problem was simply too big for any single clever trick to solve. Early control efforts were desperate and, in hindsight, almost quaint against the scale of what they were fighting. Farmers shot rabbits by the thousands, dug up and destroyed warrens by hand, set steel-jawed leg traps across their properties, and tried using ferrets to chase rabbits out of their burrows and into nets or wading guns. None of it made a dent. At the continental scale, ferreting in particular turned out to be more of a hunting sport than a genuine control method, since the number of rabbits a ferret could realistically account for was tiny compared to the millions breeding across the landscape. Fencing showed more promise, at least locally. A well-built rabbit-proof fence, dug deep enough to stop burrowing and tall enough to stop jumping, could genuinely keep a defined area rabbit-free. That insight eventually led to one of the most audacious engineering projects in Australian history, the construction of thousands of kilometers of rabbit-proof fencing across Western Australia in the early 20th century, an attempt to draw a hard line across an entire state and say, no further. It slowed local incursions in places, but rabbits already established on the wrong side of the fence simply kept multiplying, and the fence became more of a symbol of the scale of desperation than a true solution. It took until the middle of the 20th century for anyone to find something that actually worked at a continental scale, and the answer came not from guns or fences, but from biology itself. In 1950, Australian scientists deliberately released a virus called myxomatosis into wild rabbit populations. The virus originated naturally in South American cottontail rabbits, where it caused only mild illness, but when it jumped into European rabbits, the species that had taken over Australia, it proved devastatingly lethal. It was the world's first successful biological control program ever used against a mammalian pest, and the results were almost immediate and almost unbelievable. Rabbit populations collapsed by more than 90% across huge stretches of the country within a remarkably short period. The virus spread on its own through biting insects like mosquitoes and fleas, meaning it could leap between rabbit populations that never even had direct contact with one another, riding the wings of insects across the same landscapes the rabbits had once conquered unopposed. For a while, it felt like victory. Farmers who had watched their land stripped bare for generations suddenly saw pastures recovering, native seedlings pushing back up through the soil, a landscape beginning to heal. But biology has a way of humbling human triumph. Rabbits that survived myxomatosis passed on whatever genetic traits had helped them survive, and the virus itself, under evolutionary pressure to keep spreading, rather than simply killing its host too quickly, began drifting toward milder forms. By the late 1950s, host and pathogen had entered a kind of evolutionary arms race, and the disease that had once wiped out 90% of the population in an area was now killing a much smaller share. Rabbit numbers crept back up. Not to the catastrophic pre-1950 levels, myxomatosis never entirely lost its bite. And to this day, it still circulates in the wild and still helps suppress rabbit numbers, especially in wetter regions where the mosquitoes and fleas that transmit it thrive. But the miracle cure had proven, as miracle cures so often do, to be temporary. It would take nearly half a century before science delivered a second knockout blow. In 1996, Australian researchers officially released rabbit hemorrhagic disease virus, known as RHDV, a calicivirus that attacked rabbits in a completely different way than myxomatosis had. Once again, the impact was staggering. Rabbit numbers plunged to extraordinarily low levels, especially across the arid interior of the continent, where the harsh, dry conditions seemed to amplify the virus's effectiveness. In wetter, higher rainfall regions, the impact was somewhat less dramatic, but even there, the population crashed hard. For over a decade, RHDV held the line in a way myxomatosis alone never could, and unlike its predecessor, researchers didn't immediately observe the same kind of dramatic decline in virulence. It seemed, for a time, like Australia had finally found a biological weapon that could hold rabbits in permanent check. But rabbits, it turns out, are extraordinarily good at exactly one thing above all else, and that thing is surviving. Slowly, over years of continuous exposure, evidence began to emerge that some wild rabbit populations across Australia were developing genetic resistance to RHDV. Not immunity in the dramatic sense, but enough of a biological edge that fewer infected rabbits were dying, and more were surviving long enough to breed and pass that resistance on to their offspring. And so, right on schedule with the grim pattern established by myxomatosis a generation earlier, rabbit numbers began climbing again. Landholders across the country who had grown used to seeing manageable numbers on their properties started noticing more warrens, more grazing damage, more rabbits at dusk. And it wasn't paranoia. It was a genuine, measurable resurgence playing out in real time. Scientists had actually anticipated this kind of resistance and had already been working on a follow-up weapon. A new variant called RHDV2 arrived in Australia and began spreading through rabbit populations, offering a fresh biological pressure against a species that had started adapting to the original strain. Long-term monitoring conducted at sites across the country and tracked over roughly 8 years after the virus's initial detection found real, sustained impact. Researchers observed an average population reduction of around 64% across the monitored sites, with suppression holding at 5 out of 6 locations even years after the virus first arrived. Blood testing showed RHDV2 antibodies present in 60 to 70% of adult rabbits and 30 to 40% of juveniles at these sites, evidence that the virus was still actively circulating, still actively killing, and still functioning as a genuine check on rabbit numbers. It was proof that biocontrol, even against an adversary as adaptable as the European rabbit, could still deliver real, measurable, long-lasting results. And yet here is the uncomfortable truth researchers keep returning to. None of these biological weapons, not myxomatosis, not RHDV, not RHDV2, has ever fully solved the underlying problem because rabbits do not stay defeated. Every single one of these viruses has followed the same broad arc. A dramatic initial collapse in rabbit numbers, a period of genuine relief for farmers and ecosystems alike, and then, gradually, resistance building in the surviving population until numbers begin creeping back upward again. It is an evolutionary treadmill, and Australia has now been running on it for more than 70 years. Even today, with rabbit numbers still sitting at a fraction of what they were at the absolute historical peak before myxomatosis first arrived, the damage being done is still immense, still measured in the hundreds of millions of dollars every single year, still actively unraveling ecosystems across the country. The economic toll alone is staggering when you actually put a number on it. Rabbits are estimated to cost Australian agriculture around $200 million annually, a figure that accounts for lost pasture, reduced wool and meat production, damaged crops, and the ongoing cost of control measures that never really stop: baiting programs, war and ripping, fencing maintenance, biocontrol monitoring, an endless and expensive campaign against an enemy that simply will not surrender for good. But the environmental cost, though harder to put a precise dollar figure on, is in many ways even more devastating. Rabbits are officially recognized as a key threatening process for more than 320 nationally threatened species across Australia. 320. That is not a number describing damage to a handful of unlucky species in one corner of the country. That is a number describing an animal whose feeding habits are actively pushing hundreds of other species, plants and animals alike, closer to extinction across an entire continent. Part of what makes rabbits so uniquely destructive is the way their damage compounds through the rest of the ecosystem. Their grazing habits don't just remove individual plants, they prevent entire generations of native vegetation from ever establishing in the first place, which means fewer seeds, fewer shrubs, fewer trees, less habitat, and less food for native animals that depend on that vegetation to survive. Soil that would normally be held together by root systems erodes away once rabbits strip the ground bare, and that erosion doesn't just degrade the immediate area, it silts up waterways, degrades water quality, and undermines the health of ecosystems far beyond the original site of the grazing damage. And then there is perhaps the cruelest twist of all, the way rabbits inadvertently sustain some of Australia's other most destructive invasive predators. Foxes and feral cats, both introduced species themselves, rely heavily on rabbits as a reliable, abundant food source. A healthy rabbit population effectively subsidizes fox and cat numbers, allowing those predator populations to stay artificially high, even as they hunt down native mammals and birds that have no natural defenses against them. So the rabbit problem and the feral predator problem feed directly into one another, each one making the other worse, in a vicious ecological feedback loop that conservationists have been trying to break for decades. Today, in the current landscape of rabbit management across Australia, there's a growing recognition among scientists and land managers that the technical side of this fight, while still crucial, is no longer the biggest obstacle. Heidi Kleinert, who serves as the National Feral Rabbit Management Coordinator at the Center for Invasive Species Solutions, has articulated this shift plainly. The scientific tools to suppress rabbits have existed for a long time now. What's often missing is consistent human follow-through, coordinated action across neighboring properties, sustained investment in control measures year after year, even during periods when rabbit numbers look temporarily low and the threat feels less urgent. It is, in her framing, fundamentally a people problem wrapped around a rabbit problem. Because biocontrol, no matter how effective the virus, only ever suppresses populations, it never eliminates them entirely. And any suppression gains can be quickly eroded if landholders let their guard down between disease outbreaks, allowing rabbit numbers to rebuild in the gaps. This is exactly why the fight against rabbits in Australia today looks less like a single silver bullet and more like a layered, ongoing campaign fought on multiple fronts simultaneously. Conventional methods that were once considered the primary weapons, baiting programs using registered poisons, warren ripping to physically destroy underground breeding sites, exclusion fencing to protect particularly sensitive areas, remain essential parts of the toolkit even now. But researchers are increasingly focused on biocontrol as the only method capable of suppressing rabbit numbers at a truly continental scale, something no amount of manual baiting or fencing could ever achieve given the sheer size of the country and the sheer speed at which rabbits reproduce and spread. What's changed most significantly in recent years is the strategy behind developing new biocontrol tools in the first place. Rather than simply waiting decades for a naturally evolving virus strain to emerge on its own, the way both original myxomatosis and RHDV effectively did, scientists working under a coordinated national rabbit biocontrol pipeline strategy are now taking a more proactive approach. By growing existing rabbit viruses like RHDV in controlled laboratory cell cultures, researchers can actually guide and accelerate the virus's natural evolutionary process, essentially fast-forwarding through generations of viral adaptation to stay one step ahead of the resistance that rabbit populations inevitably develop. It's important to understand that this isn't about creating some entirely artificial engineered pathogen from scratch. It's about accelerating a process that already happens naturally in the wild, just doing it faster and more strategically in a controlled setting, where scientists can observe and guide the outcome rather than simply waiting and hoping. The ultimate goal of this pipeline approach is to build a repeatable system for generating future biocontrol options on an ongoing basis, so that the next time rabbit resistance builds up against whatever virus is currently in circulation, there's already a new candidate strain waiting in the wings, ready to be deployed, rather than starting the search from zero all over again. Beyond this more immediate cell culture approach, researchers are also exploring longer-term possibilities like genetic biocontrol, methods that would work at the level of rabbit DNA itself to suppress reproduction or introduce traits that reduce population growth over time. These genetic approaches remain, by the admission of the scientists working on them, years, if not decades away from any kind of practical, field-ready deployment. The science is complex, the regulatory hurdles are substantial, and the ecological risks of any genetic intervention need to be understood extremely thoroughly before anything like that could ever be released into wild rabbit populations across an entire continent. But the fact that researchers are even pursuing it shows just how seriously Australia continues to take a problem that, on the surface, might look to an outsider like it was solved decades ago when myxomatosis first arrived. Alongside all of this scientific effort, there's also an ongoing investment in monitoring and information sharing that didn't exist during the earlier chapters of this saga. Researchers at institutions like the CSIRO now maintain continually updated calicivirus maps of Australia, tracking exactly which rabbit-targeting viruses are circulating in which regions, at what times of year, and with what level of intensity. This kind of real-time data helps land managers time their own control efforts more strategically, coordinating baiting and warren destruction to work alongside natural disease outbreaks rather than against them. And it also helps veterinarians and pet rabbit owners protect domestic rabbits from these same wild viruses through vaccination and careful biosecurity practices, since these diseases don't discriminate between a wild rabbit in a paddock and a beloved pet rabbit in someone's backyard hutch. What makes the entire history of this crisis so genuinely sobering is how it keeps circling back to the same fundamental lesson, decade after decade, generation after generation. In 1859, a handful of rabbits released for the harmless pleasure of weekend hunting became, within 70 years, the fastest mammal invasion the world has ever recorded. In 1950, a virus that killed 90% of the rabbit population within months looked like a permanent solution, until evolution quietly, patiently eroded that. Victory over the following decade. In 1996, a second virus achieved similarly dramatic results, only for resistance to begin creeping in over the years that followed. Each time, humans have declared some version of victory, and each time, biology has proven more patient and more adaptable than any of us expected. Rabbits, unassuming, soft-eyed, seemingly harmless little animals, have humbled some of the best scientific minds Australia has ever produced, Not once, but 3 separate times across more than a century and a half. And so the fight continues today, not with the same desperate energy of 19th century farmers digging up warrens by hand or offering unclaimed cash prizes for a solution nobody could deliver, but with a far more sophisticated, more patient, more scientifically grounded approach that nonetheless carries the exact same underlying humility. Nobody working on this problem today believes there is a single final solution waiting just around the corner. What they believe, instead, is that the fight has to be sustained indefinitely, layered across multiple methods, adapted continuously as rabbits continue adapting to whatever is thrown at them, and supported by exactly the kind of coordinated, consistent human effort across communities and properties that Heidi Kleinert identified as the real missing ingredient all along. It might be, as she put it, a rabbit problem. But solving it, or at least holding the line against it, has always required, and will always require, a distinctly human solution. There's another angle to this story that rarely makes it into the shorter tellings, and it has to do with just how much of Australia's national identity and national infrastructure was shaped, directly or indirectly, by the presence of these animals. The rabbit-proof fences built across Western Australia in the early 20th century weren't some minor local project. The longest of these fences stretched for well over 1,000 miles, cutting almost the entire vertical length of the state, built by hand, by small teams working in brutal heat, digging trenches, sinking posts, and stretching wire mesh across some of the most remote and inhospitable terrain on the planet. It remains one of the largest unbroken fences ever constructed by human beings anywhere in the world, and it exists purely and entirely because of the rabbit. Entire government departments were established, entire careers built, entire scientific institutions funded and staffed for one single purpose across generations: to fight back against an animal that most people outside Australia still picture as a gentle, harmless creature nibbling lettuce in a garden. That disconnect between the rabbit's soft, unthreatening reputation everywhere else in the world and its status in Australia as arguably the most destructive introduced species in the country's history is part of what makes this story so difficult for outsiders to fully grasp. Ask most people what they picture when they think of an invasive species wreaking havoc on an ecosystem, and they'll probably imagine something dramatic: a predator, a venomous creature, something with teeth or claws or a menacing reputation already built in. Almost nobody pictures a rabbit. And yet here in Australia, the rabbit has done more measurable ecological and economic damage than almost any other introduced animal on record. More than feral pigs, more than cane toads in most direct economic comparisons, more than almost anything except perhaps feral cats when it comes to the compounding downstream effects on native wildlife. It achieved all of that, not through aggression or predation, but simply through eating, breeding, and digging, at a scale and a speed that no ecosystem on the continent had ever evolved the tools to resist. It's also worth sitting for a moment with just how differently this story might have unfolded under slightly different circumstances. If that fire at Barwon Park had never broken out, if the fencing around Austin's original enclosure had held just a little longer, or been built just a little sturdier, the entire trajectory of Australian agricultural and environmental history might look completely different today. That's the unsettling truth sitting underneath so many of history's great ecological disasters. They often hinge on genuinely small, almost accidental turning points: a burned fence, a handful of animals, a moment of bad luck compounding a moment of poor judgment. Thomas Austin wasn't trying to destroy a continent. He was trying to recreate a familiar weekend pastime in an unfamiliar new home. The gap between that modest personal intention and the continental scale catastrophe that followed is, in many ways, the entire lesson of this story distilled down to its rawest form. Small actions, taken without full understanding of the systems they're being introduced into, can cascade into consequences that unfold for centuries, and that no single generation, no matter how well-resourced or well-intentioned, can fully undo. $200 million a year in agricultural losses. More than 320 threatened species pushed closer to the edge because of a single introduced grazer. 70% of an entire continent conquered within 70 years by an animal with no natural predators waiting to stop it. 3 separate biological weapons deployed across more than a century, each one a genuine scientific triumph in its moment, each one eventually eroded by the same relentless evolutionary pressure that has defined this entire saga from the very first release at Barwon Park in 1859. That is the true scale of the aftermath of Australia's rabbit invasion, and it is a scale most people, understandably, never fully grasp. It didn't happen in a single dramatic event, a single headline, grabbing disaster with a clear beginning and end. It happened slowly, relentlessly, one litter of kits at a time, one grazed seedling at a time, one eroded hillside at a time, accumulating over more than 150 years into one of the most significant, most enduring, ecological catastrophes any nation on Earth has ever had to confront. And more than a century and a half after Thomas Austin's rabbits first slipped through a burned fence line into the Victorian countryside, Australia is still out there fighting them, still developing new tools, still coordinating new strategies. Because the one lesson this entire saga has taught again and again and again is that with rabbits, the fight is never really over. It only ever pauses